we're going to go through the parent functions, specifically what you need to know about each function for the parent function memory quiz. So I'm going to highlight the name, the equation, the shape, and the specific things on the graph that you would need to know. So let us start off simple, constant function. So f of x equals 1, or y equals, it could really equal any number. Okay, so I could have, let's say, y equals 5, or f of x equals 5. What are the key properties on this thing? It is a horizontal line, and it goes through whatever that y equals number is. So f of x equals 1, y equals 1 goes across y equals 1, y equals 5 is a horizontal line across y equals 5. So what am I looking for? I'm looking for a horizontal line that goes through whatever number we say it does. Identity function, you can also call this a linear function because it's f of x equals x or y equals x. So what are the things about this thing that are really important I would need to see? Well, it's a line with a slope of 1 through the origin. So it actually goes through 0, 0, and as you can see, it's got a slope of 1. So linear or identity function is y equals x, f of x equals x. It is a line, slope of 1, goes through the origin 0, 0. Absolute value graphs. So you can see it here. F of x equals absolute value of x, or y equals absolute value of x. So what are the most important characteristics of this? The shape. It is a V, not a curve, a V. Two lines, segments, coming out from, or two rays coming out from the origin. It has something called a vertex. That's the corner piece right here, and that's on the origin, 0, 0. And then the slopes of these two lines are positive and negative 1. So the right side has a slope of positive 1. The left side has a slope of negative 1. So absolute value has a shape that's a V. The vertex is at the origin, 0, 0. And the slopes are either positive 1 or negative 1. Greatest integer function. So this graph is a little misleading. You would need more than just these little horizontal lines to get full credit. Okay? There is a solid dot on the left side, a horizontal line, and then an open circle on the right. And that's for every single one of these lines. Now, you don't have to draw them all on your quiz. That takes too long. I get it. But there's no arrows here. There's no arrows at all, just a bunch of these steps. That's why sometimes this is called the step function, or sometimes it's called the floor function, because you're rounding down. This is always a round down situation. Mr. Ratliff, when would you ever use this in real life? Well, let me ask you a question. If you have something that costs $3, if you have $3.56, but something costs $1, you can only buy 3 of them. Because if you round this down, it's going to equal $3. That's an example of that in real life. So, what would I need to see on the quiz? On the memory quiz, you need to know the name, the greatest integer function, the brackets around the x, and then the general shape of this guy. Okay, so things that I'm looking for, the general shape looks like this, and then it steps up every step and comes back the same way, and at least one of those points is on the origin 0, 0. So one of your steps starts right here at 0, 0. Greatest integer function. Quadratic function, you're back to stuff you know. This is a parabola. Some things that are important is the shape. It may makes a U shape, and the vertex is on the origin. I'm not super worried about the slope of this yet. We'll talk more about that when we get to transformations. I just want you to know the quadratic function is y equals x squared, the shape is a parabola, and the vertex, the turning point, the minimum, is on 0, 0. A cubic function. So y equals x cubed, or x to the third. Okay, so what's some important things here? Again, the shape, it goes up, flat, and up. And this flat spot right in the middle has a name. You don't need to know it right now, but we will learn it soon enough. It's called a point of inflection. And that point of inflection is on the origin, on 0, 0. So I need you to know the general shape, and I need you to know the point of inflection, the POI, point of inflection, is on the origin 0, 0. Reciprocal function. Sometimes this is called the rational function. Rational just means fraction. It's 1 over x. Okay? So what are the important parts of this graph? Well, obviously the shape. It has a weird U shape in the top right and in the bottom left. These things have arrows on them. What else matters are these, the vertical and the horizontal asymptotes. The asymptotes are y equals 0, that's the x-axis, and x equals 0, that's the y-axis. So the reciprocal or rational function, 1 over x, has asymptotes on the x and the y-axis, and then the shape has these little U-shaped things along the top right and the bottom left along the asymptotes. Square root function, you can see here, y equals square root of x. I want to point out this one starts at the origin. So the general shape, looks like that. But it has a starting point. So there needs to be an actual dot right there. Square root function. Cube root function, so cube root of x. Again, what's important here? The shape. It's like a sideways cubic function with a really important point right there in the middle. Remember, this point in the middle has a special name. It's called a point of inflection. So when I'm going to grade this, I'll count it correct if you put the shape correctly and the point of inflection at the origin of 0, 0. Exponential function. This example has 2 to the x. It can be any number to the x. So 3 to the x, 4 to the x. A lot of times we'll use e to the x. We'll talk more about that this year. What are the characteristics of this graph? Things you have to get full credit on your quiz. Well, one thing you have to draw is the horizontal asymptote. Okay, this thing has a horizontal asymptote at y equals 0, the x-axis. Another thing you have to draw is the y-intercept. This thing has a y-intercept of y equals 1. And then lastly, you got to get the shape right. It goes along the asymptote, through the y-intercept, and then up. So when I'm going to look for this exponential function, when I'm looking to grade it, I'm looking to see on the graph, does it have a y-intercept of 1? Does it have a horizontal asymptote at y equals 0? And is the general shape correct along the asymptote and up through there? Logarithmic function. So this one's a little bit misleading the way that it's written. This is like a sideways exponential function. It really comes along through here like a hockey stick and then down along the x or the y-axis. It doesn't just stop there. So what are its defining characteristics? Well, since it's a sideways exponential, It has a vertical asymptote at x equals 0, the y-axis. It has an x-intercept at x equals 1. Exponential has a y-intercept at y equals 1. The logarithmic has an x-intercept at x equals 1. And then the general shape. Remember, it kind of looks like a hockey stick. It goes along the y-axis, through the x-intercept, and then out. So to get full credit on the quiz, I'll need to see the asymptote, I'll need to see the x-intercept, and I'll need to see the shape. Sine function. So we're going to spend way more time on sine, cosine, and tangent in the second half of this year. For now, I just need you to get a good idea of the shape. The shape is a wave between y equals -1 and y equals 1. So the highest it ever goes is +1. The lowest it ever goes is -1. The other thing you need to know is that the sine curve goes through the origin going up. So the curve goes through the origin and up like that. And then just wiggles like a wave between y equals 1 and y equals -1. Where does it cross? We'll talk way more about that in the spring. For right now, I just need you to recognize that the sine graph looks like a wave bouncing between 1 and -1, going through the origin, going up. Cosine function. Again, this is a wave, just like the sine function. It's also between y equals -1 and y equals 1. So what's the difference here? This has a y-intercept that is 1. See, it's up here. And it's symmetric on both sides. We say it has even symmetry. Where does it cross the x-axis? I'm not worried about that for right now. We'll talk about that in the spring. The cosine function is a wave between -1 and 1 and has a y-intercept of 1. And then finally, the last one, the tangent function. This one is the craziest looking one. So the things that you can't see is there are asymptotes in this graph. It's hard to draw because they're so close together. So this is a really hard graph to see, to visualize. So what am I going to look at? I'm going to look at the general shape. Did you draw the shapes like this going up? Is your center one through the origin? So the center point there is through the origin. And it has vertical asymptotes. How often is there a vertical asymptote? How often is there a dot that's on the x-axis? Again, we'll talk way more about that in the spring. For right now, I just need you to get an idea of what the tangent function looks like. It's got those vertical-looking squiggles with vertical asymptotes that separate them, and it goes to the origin 0, 0. So what's your quiz going to look like, your memory quiz? Well, I'm going to give you one of three things. I'm either going to give you... This is crazy. We're not deleting this. I'm this far in the video. We're going to finish out. The memory quiz, I'm going to give you one of three things. I'm going to give you the name of the function, or I'm going to give you the equation of the function, or I'm going to give you the graph of the function. I'm going to give you one of those three things, the name, or the equation, or the graph, and then I'm going to ask you to give me the other two. If I ask you to graph, remember, you're looking for things like specific points. We talked about a point on every single graph, whether it was the vertex or the x-intercept or the y-intercept. I'm looking for asymptotes. I'm looking for the general shape of this graph. So when you go to graph something, if there's supposed to be a specific point, put a dot on where the specific point is supposed to be. For example, on the exponential graph, okay, you can't just tell me it's this. You got to tell me that there is a dot on the y-intercept y equals 1. Put a solid dot there. Don't just get close. Put a dot there. And you've got to tell me the asymptotes. If there's supposed to be an asymptote, I better see a dotted line there, or else you'll lose points. And then the general shape, people mostly get that right. So remember, on the memory quiz, there's 3 things you have to know. You have to know the name of the function, the equation of the function, and the graph of the function. And on the graph, you need to remember specific points that we talked about in this video. You need to remember an asymptote if it does have one, and you need to remember the general shape. I will give you one of those 3 pieces of information. You have to provide the other 2.